to record, and we are recording.
All right.
Okay, so share screen. This is processors. Okay, so we're gonna identify the core components of a CPU, describe the relationship of CPUs and memory, explain the varieties of modern CPUs, select and install a CPU, and troubleshoot CPUs. So the CPU, we should all know at this point, is the central processing unit, right?
Mm-hmm.
A lot of times people refer to the whole tower as the CPU. That is incorrect. CPU is the central processing unit. It is the brains of the operation. This is what does all the computing and calculations that makes things happen. In millions of operations in milliseconds. So the processing speed makes the CPU look intelligent, right? Because it processes things so quickly, it seems like the CPU knows something, but it's all about input and binary code, which is how the CPU gets its information. We send the information via our input devices, whether it be keyboard, mouse, or whatever, and then it does calculations, and then the processing, right? We talked about the 3 steps: the input, the processing, and then the output. And the CPU is Grand Central Station for everything that happens within the computer. Okay, wait. So the chapter that had the visible computer, y'all went through all the parts or no? Like, let me see if I said to, where's my, wait a minute, let me escape. Oh, if I said to, who else says they have voice? Soraya, can you speak?
Yes.
Okay. So if I said, tell me the main 5 things you need to put a computer together, what would you say?
Oh, you stumped me on that one. I don't know.
Okay. So, DeMonte.
I got.
Yeah.
So, DeMonte, the chapter with the physical computer, it didn't give the overall of like what
Yeah.
the visible computer. It didn't talk about the different components.
Yes,
No.
he did.
Wait, did it?
We talked about it.
Okay.
Even
So,
putting
Cosmic.
it in different boxes.
Okay. So, Cosmic, tell me what you think the 5 main, like what you absolutely need to be able to put a computer together.
Okay, a motherboard, processor, RAM, put it together. Like you said, a case isn't really that important. You don't need a case.
Right, because we've seen some crazy systems
Power supply. Power supply would
we need
be
some
important.
power. We do need some power.
I have somebody helping with the last one. My mind's blank.
Hard drive.
There we go.
Some storage.
Yeah.
Yeah, because we gotta. Well, in order for it to function, we gotta be able to put the operating system somewhere. So that means that we need to have a hard drive. But we all know we can put it together, and without an operating system, right?
Yeah.
Because the operating system. So let's differentiate between the once you put all the components, the hardware components of a computer together, they are managed by what's called the BIOS, right? The basic input-output system. So you can go into the BIOS and see everything and all the hardware and that it's all functioning properly without having an operating system. The BIOS operates outside of the operating system. The operating system is once you get in, right? It tells you how, like for me, I always say the BIOS is like the operating system of the hardware, and the operating system is the system that manages software, like the applications and processes and information. And the BIOS manages the basic input output, just like it says, basic input output system. Nowadays, we have what's called legacy BIOS, and we have what's called UFI, which is like it's like a combination between a basic text-based version of the BIOS and a little bit
Uni-
of graphical
unified
input.
unified extensive firmware interface.
Mhm.
Okay.
And we'll get into that. We'll definitely get into that. But
You
UEFI. So when we talk about processors, so y'all said y'all talked about this with the man in the box, right?
Right.
Well,
So
actually, Peter, he gave an analogy for the CPU being a city, and he talked about buses and transporting. We didn't really talk about the man in the box that much.
Oh, that was in reference to the motherboard.
motherboard.
Oh.
Okay.
All right, so don't ask me any questions.
I was like, wait a minute, I'm confused. Right. So maybe I should have listened to the recording before I came in here with y'all so I could see what happened while I was going. And I truly apologize for missing that space. So and the reality of a CPU is it's like having a person in a computer, right? And the CPU does whatever you want it to do. But it's all about what goes on inside the computer. So and then how we communicate with it. So and that goes through how we do input, right? That's how we communicate with with the CPU. So how do we talk to the man in the box? We need some way to talk to the guy inside the box. So has anybody read this part of the chapter?
Yes,
Who's that?
Pam.
Okay, Pam. So what did you find out about this analogy with regard to the man in the box?
Uh, okay, so the man in the box is looking for instructions.
Mhm.
And the way that instructions are given to the man in the box is with, well, I'm going to use the light bulbs. Apparently, there are light bulbs on there, and I know they're not really light bulbs, but I'm going with that analogy.
Okay.
There are light bulbs on the inside of the box and corresponding light bulbs on the outside of the box. And when one light bulb lights up on the inside, that same light bulb on the outside of the box lights up. And so the instructions or code that comes in is what lights those light bulbs up. Is that
Okay.
close? Is that close?
Uh-huh.
Okay. Okay. Is that enough?
Okay. Uh-huh.
Thank you.
She like, are you letting me off the hot seat right now? Thank you very much. Right? So it's all about you may wait, somebody just sent a message. Hold on.
You made. Oh,
To refresh. Oh, what's happening? Somebody lost connection. Oh, I don't hear. Yeah, sometimes with if you lost your sound, you duh. I did it again. If you lose sound, sometimes you need to drop out of the meeting and come back in again. Y'all see that on my screen? I am sharing my whole screen, right?
We can see the box, but we can't see what you're typing.
Okay. What was I going to say? So the man in the Somebody said the man in the box ain't working. That's funny. Um, um, so I don't know how I feel about this. I mean, the analogy makes sense. How about this?
There
Let's
has to
go
be
to
there has to be another way that we can make an analogy that makes sense.
what? It doesn't make sense to you?
Like when I so what's today? Tuesday. So on Sunday, when I saw that man in the box thing, I was like, wait a minute.
Mhm.
I had to like think on my feet for that because I was like, what?
So, Demonte, if you had to explain how information travels, and y'all just, I'm trying to get,
The bus.
if you had to explain how information travels, right,
Right.
with regards to the processor, what would you say?
I would say that it's like a oh, I think I got it. I think I got it. I
Okay.
think it's like a chef, and you give the chef the ingredients, and they take the ingredient, and you like you got to make what you make out of it, you know, and then give it back. Or
And give it back.
maybe I'm thinking something else. That's a tough one.
You mean the physical way in which we communicate with the central processing unit?
Right.
Well, that would be the bus architecture.
Right. But not necessarily the physical way, but I mean like we try to understand the concept of we give information to get information back, right? To the processor.
Information back. Okay.
The user
Right?
interface.
Right, through the user interface. Like
User interface.
we type or we click on a icon on the graphical user interface, which is the GUI, which tells the processor open this program, right? So you click on Microsoft Word icon on your desktop, and a whole bunch of processes have to happen because it's gonna go pull from Microsoft Office to open Microsoft Word. It remembers the last documents you used when you were in Microsoft Word, right? So we pulling from the RAM because the the random access memory holds little bits and pieces of information. We'll get into that. Right? And it's going to say go to this space where the documents were last opened or last stored and the last key that was typed in the document. And you know how like Microsoft Word has this auto recovery. Like even if you don't save it, it has this auto save feature that takes you right back to the last thing you did in a document, in a temporary holding type of space. All of that comes from information that's going to the processor, telling the processor to go here, pull this information, and give it back out. So all of that, like you said, all of that goes across the information buses, the system bus, and all of the different. Wait, how did I get to the bottom of the page? Lord have mercy, I done went and lost my mind.
Wait, is this screen shared or out?
No, not right now, cause I'm trying to get to the chapter so we could talk about this processing situation. Cause it's not a situation where I could just go with the what you call it, PowerPoint. This is why it's very, 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 very important to read the chapters in preparation for going into this. Okay, so if you go in the book to approximately page 126, 126 starts with the man in the box, right? So it's saying he can perform virtually any mathematical function, manipulate data, and give answers very quickly, right? And that's the CPU, and that's the gist of the CPU. It calculates things really quickly, and is able to spit it back out to you. The guy is potentially very useful to us, but there's a catch. He lives closed up in a tiny box. Before he can work with us, he must come up with a way to exchange information with him. Imagine that we install a set of 16 light bulbs, 8 inside the box and 8 outside of the box. Each of the 8 light bulbs inside the box connects to, and that's what, was it Pam, said about the light bulbs, right? So each pair of light bulbs is always either on or off, which is binary code. Binary code is a series of zeros and ones. One being on, 0 being off. So is that bit, say again?
Oh, I was just saying static RAM. SRAM. The cache.
You in a whole nother space. Hold up. So you can control the 8 pair of bulbs by using a set of 8 switches outside the box, and the man in the box can also control them by using an identical set of 8 switches, right? The light bulb communication device is the external data bus. So if we look at, so when either you or the man in the box flips the switch on, both light bulbs go on. And the switch on the other side is also flipped to the on position. If you or the man in the box turns the switch off, the light bulbs on both sides are turned off, along with the other switch for that pair. So it's like an alternating pattern of, because everything that goes on in a computer is run by binary code. Everything. Who said they have no sound? Jay, I'm not sharing my screen right now. I'm in the book, and so everybody has a copy of the book, right? Yeah. Okay. So let me do this. Okay. Oh, why is this doing this? Okay. So who has? I hear echo. So creating on and off patterns with the light bulbs that represent the different pieces of data or commands, you can send that information to the man in the box, and he can send the information back in the same way, assuming that you agree ahead of time on what the different patterns of lights means. So the thing we need to understand is all of the information is sent across different buses, which are physical buses on the motherboard of the computer. So it's different. It's the data bus, it's the system bus, and it's all about the different ways that information that we communicate, like the CPU communicates with the memory communicates with the IO, the IO ports, the input output. It's all about the transfer of information. So this is a picture of the CPU. Some CPUs have pins, and other ones have. We have what's called the pin grid array and the LAN grid array. So the difference between the two is this is one with the pin grid array because it's missing pins. So if you can visualize, if you look inside a computer, right, and you look in the motherboard and you look in the CPU socket, CPU that has a pin grid array, the pins are on the CPU. And when you put it down in the socket, each pin has a hole that it corresponds to, that it goes down into within the socket. Alternatively, with a LAN grid array, it's like a bunch of raised dots. And if you look into the CPU socket, it's pins in the CPU socket. that these connectors, you know, sit on top of, and that's how they are able to how the information is transferred through the pins, whether the pins
Okay,
are
so
on the
pin
Go ahead.
grid array is on the
CPU. Right.
Land grid array.
The pins are actually in the socket. So
On
you'll
the
see
socket,
if
they're
you
not really
have,
pins too much, right? They're like some sort of raised bumps.
right, that's the land grid array.
Yeah, land grid array.
So it's like the pins are made of gold, which is crazy, like real gold. Because, and that's why you'll see like a lot of these Chinese companies and a lot of these foreign companies are buying up old computers because they're removing the gold components from the inside and melting it down.
Yeah, there's also silver and platinum inside of computers. Is there not?
No,
No?
no. What do you mean with regards to what components?
I'm not sure. I'm just talking.
Oh, okay. Right. Jay, you're absolutely right. So they're mining gold from these different resources. And the crazy thing is we're going to talk about the two main manufacturers. Oh, okay, I'm getting somebody's feedback. We're going to talk about the two main processor manufacturers. Anybody know the two? Not you, DeMonte. DeMonte, somebody else?
AMD,
Say that again.
Intel and AMD.
Intel and AMD, exactly. And if you'll notice that the majority of the more modern Intel processors are land grid array. AMD is still rolling with the pin grid array.
Peter and I had a fight last class.
About what?
Processors, his Intel versus my AMD, and we
Oh,
had to pull up the stats and everything. And I don't want to talk about it. Let's keep going.
You trying to say he took an L?
Nah, he
You lost it. You lost it. Keep it real.
Monty, we were there. We were listening. Come on, Monty.
Yeah, that i7 processor that Peter has is a beast. We've had discussions about that processor many times. And right, of course it does. Today, the same processor. Like you know how, like as things get older, a lot of times you can get things for cheaper. That's why, like you can call a computer that you bought 3-4 years ago a dinosaur right now. Like compared to the way things move so quickly. So a lot of times, like example, solid state drives, which we'll talk about when we get to hard drives, are like hard drives with no moving parts. Basically, they're like big flash drives, big USB drives.
I'm just saying, I know my $153 processor wasn't competing with that grand Intel, but I'm balling on a budget. So
I feel you, and that is why AMD continues to have their share of the market because their processors are more affordable. They will try to say that their processors are comparable, and they always bring out a processor that says this processor is comparable to this Intel processor. But it's also levels to the Intel processor, right? Like you can have an i7 that costs $350, and you can have an i7 like the one Peter has that costs $1,000. It's all about processing speed, how much cache, all of that other stuff that weighs into the heftiness, if you will, of processors. The things for the basic thing that we need to know about processors are that this is where the information is processed, right? That don't need to say, that sounds redundant. The processor is where the information is processed, but that's the truth. So registers are like tiny parts. I feel like I want to use this book, but now I'm seeing Like, because this book is made to really, like, for you to read from cover to cover to understand what's going on. You know what I mean? So from a teacher's standpoint, it's kind of difficult because it's like, it's still rolling with this man in the box type of scenario. So, it really isn't like defined in I need to what I need to get across to you guys. So so registers are tables that store internal commands and data on a computer. Is that anything like the man in the mirror? Carrie, you funny. But it's like, um see, we have like CPUs got a bunch of different registers, but they have general. We could talk about the general purpose ones, right? AX, BX, CX, and D, and you'll see these terms all over the place. This note says the 8080 was the first CPU to use the four AX to DX general purpose registers, and they still exist in even the latest PCs, but they have a lot more light bulbs. In 32-bit processors, the registers add an E for extended, so EAX, and then for 64-bit registers, they get a R, which is how does E equal 32 and R equal 64? But, oh, okay. So let's go with their example and see if we could get some understanding from this. So it says we're just about ready to put the man in the box to work, but before you close the lid on the box, you must give the man one more tool. Remember the code book? I don't remember the code book. Let's make one to enable us to communicate with him. Figure 4.7 shows the code book we'll use. We'll give one copy to him and make a second copy. So you see here it says the next line is a number and put the so this is how commands work with regard to data going across the bus. So when this binary code is put in, which is 1000011, that means move number 7 into the AX register. This is machine language. That's why you'll see when you become a tech, you'll see when you look into logs, error logs for computers, you might see machine check exceptions, machine language exceptions, machine language errors. That means some lines got crossed somewhere, right? So the lights that would correspond to these light bulbs is all about different commands. And every combination is a different command. So if you're looking at this code book here, it says, it says for this light is this meaning. And for this binary combination is another meaning. And that's how information functions within the CPU. It's all machine language done in binary code. And registers hold that information. And the registers, the information sits in the register and it's always there, and it's information that comes in and out. Just like you ever when you use the C cleaner and it says that it asks you if you want to save these changes to the registry. Y'all remember that? When you did the cleaning through, right? Because processing, a huge part of processing is the exchange between the CPU and the memory. So a lot of times the CPU has these small spaces where it stores information that it constantly uses. And so that just like RAM stores information that so that you don't always have to go back to the hard drive for some information. It's like a table in the middle of the library. If the hard drive is the library that has all the information, right? The memory sits, the RAM and the cache is like the temporary memory within the CPU. These are temporary storage spaces for regular things that happen within the processor or within the memory so that we don't always have to go all the way back to the starting line or pull all the way from the hard drive to get information that we regularly use or that we're going to use again right now or later, which is why a lot of times, you know how when you call customer service and the first thing they say is, did you restart your computer? Right? Because when it gets into the memory of it, the RAM, it holds on to little bits, and little bits over and over again until you refresh the memory. And the only way you can refresh it is to remove the power from it. And then we're going to talk about synchronous and asynchronous memory and the volatile and non-volatile memory. Question?
Question on that point.
Hmm.
Is that why some people suggest it's a good idea to always shut your computers down versus putting them to sleep?
Yes. Yes. Because putting it to sleep doesn't remove the information. And we're going to talk about, when we get into Windows, we're going to talk about the difference between sleep, hibernation, and what exactly is stored and kept during those times. No, Shirley, is not the same thing as a defrag, because a defrag is like, when it comes to the hard drive memory, because the disks in the hard drive or even in a solid state, different bits and pieces of documents and information are stored all over in different spaces on the hard drive. And sometimes, because the process that it takes to pull it all together slows as more information is stored because it's fragmented. So, say if we have the word establishment, right? And if the memory stored the ES all the way over there, but it stored the TA over here, right? Every time it pulls that information, it has to go and look into all the chopped up spaces to pull it together, right? So defragmenting does exactly that. It takes all the fragments and puts them together, or more closely together, so that the memory or the drive operates more quickly. And defragging is about the drive as opposed to memory, which is a whole other thing. But we'll talk. And you also notice, like, nowadays you don't really have to do a defrag of a machine the way we used to have to do it, because they've made it a part of Windows, the constant, like, rearranging of information and defragmenting. Sometimes, of course, it gets out of control and you actually have to go into doing a defragmentation, but it's becoming, parts of it is becoming part of the Windows process. And also a lot of the cleanup programs that we use does exactly that. Rearranging of information to keep it all together so that it's not as fragmented, and they're able to get the bits and pieces from other places. And what I think I'm gonna do going forward is I'm gonna keep telling y'all to read the chapter, but I'm gonna pull from somewhere else to be able to give you, according to their slides, and give you the information from my own space. Because trying to get it, I mean, like I said, this book is great for read this book from cover to cover to really get it. But from a teaching standpoint, it's kind of difficult. So,
Okay, Mojo, this is Pam. I just sent a note. The CPU code book, is that important to know for the exam, or?
because there's no real CPU code book. That's
not
just
that
like
example, but in general, just understanding binary enough, because none of that makes sense to me.
the only thing that we need to understand about binary is that information. A bit is a bit is one of those 8 parts, right? A byte consists of 8 bits, and the 8 bits is how everything moves with regards to information in the computer. So, and when we get into subnetting, then we'll talk about what this combination of ones and zeros actually equals. I don't want to speed ahead to that because it's just gonna confuse you.
Okay.
But um, right, right, and it's 8 bits to a byte. That's why, and then we're gonna talk about the different sizes, like bits to bytes, to words, to megabytes, to kilobytes, to right. It's just multiplication. 1,020, and it goes at a root of base 2, not base 0, like hexadecimal the way we do. So that's why I'd always go yes, yes, cosmic. So as we go along,
Not for
you'll
everybody
see,
else.
huh?
I'm doing that for everybody else so they can see it.
Oh, okay. But they gonna say it in the as we move forward. Yeah, I'm not me and this man and this clock and this, yeah, he killing me. Clock speed, bus speed, will this what I'm gonna do. Hold on, let me see if I go. Has anybody been to ProfessorMessa.com?
I have. Well, I've been on YouTube. I haven't been to .com. I've been on YouTube all the time.
Professor Messer has the picture guide. Like he has the important things that you need to study for the exam. And I actually got it. It's very compact and it helps you to. It's like $10 each.
Yeah. The course notes.
Yeah.
Uh-huh. But I'm trying to see if I could get, if I can find, that's what I'm saying. Like, that's what I was getting ready to say. I'm sorry. So, CPUs for the test, the most that we'll need to know about passing the test is about the different CPU sockets. It's not really gonna, has everybody looked at the objectives? Please say yes. Because if not, we don't go to the objectives right now. Because the objective is
Let's go over them again.
to pass the test. So, wait a minute, let me see if okay. Y'all can see this? Yes, no, maybe so?
Yeah.
Okay. So, if we go with this first the objectives is all, it goes according to, wait a minute. Exactly according to what you need to do and the questions that you need to answer for the test. Exactly that. So look, objective 1.0 is hardware, right? And 1.1, given a scenario, configure settings and use BIOS/UEFI tools on a PC. So the questions it'll ask you is, you see it really, like, it asks about clock speeds. You might see one question about clock speed. When it comes to the CPU, it's about knowing the sockets. Knowing the sockets, knowing which sockets go with which manufacturer, and what if you have this kind of socket, what kind of processor goes into this socket.
Mm-hmm.
Now, huh? Say that again.
Yeah, I said, yeah, you're right.
So, like, as much as I want y'all to read the whole book, my my objective is to get you focused on the objectives. You know what I'm saying? Because once you understand what the objectives are, then you know exactly what you read. Yes, you need to read the whole book. Yes, you need all the information. But in order to pass this certification test, you need to focus on these objectives. So this first one is given a scenario, configure settings, and use BIOS. So it's gonna ask you a question like go into the if you go into the BIOS and this you where would you go to change this and this and that? Or if you have if you're trying to boot the computer and it keeps saying non-system disk error, what could possibly be the problem, right? And once you understand the objectives and things about the boot sequence, then you know most likely the person has a disk, a CD in the disk drive, right? Because if the boot sequence is saying the first thing you boot from is CD or DVD, and then you go to the hard drive, which the 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 basic configuration for boot sequence is just that, to look for the DVD first. Why? Because if you're experiencing problems with the hard drive, you want to be able to put a system disk or
I hear an echo.
me too. Hello? Okay. So you want to be able to boot from somewhere else besides the hard drive first, which is why the boot sequence usually goes DVD and then hard drive, or DVD or Pixie boot, which is booting from a network location, which we'll talk about, and then look for the CD and then look for the hard drive. So if you have something in the disk drive and it's trying to boot from the disk drive, that's why it's going to give you the error. Whereas if it doesn't detect anything in the boot drive, then it moves on to the next thing in the boot sequence, which is the hard drive. And then that's where it'll find your OS.
Yeah, I can't start my computer with my phone plugged into the USB port.
So that means that your boot sequence has the USB port before the hard drive in the boot sequence. Because a lot of people, now you have bootable USB drives. Yeah, right? People can put ISOs on USB drives and boot from the flash drive. So if you have your phone plugged into the USB and it keeps stopping and it won't boot, most likely your boot sequence has the USB before the hard drive. Because a lot of times you realize once you unplug it and restart, then it works. Because then it goes to the USB port, it doesn't see anything, so then it goes to the next step. Jay Suleiman, you have a question?
Yes. This objective page you're looking at,
Mm-hmm.
this is from the actual book? It's in the book?
No. This I sent the links out to this when we had the very first, well, maybe the kickoff meeting, because these two documents, which
I missed the kickoff meeting. I was at the first class.
okay, so I'll post links to the both objective pages, so that this is the objectives for just 901,
Okay.
and then there's another document for 902.
Oh.
But you need to have these documents and understand that this is what you need to hone in on, because the questions ain't gonna be about nothing but this. It's gonna be a lot of other information in your book, in your different resources that you use, but your focus is the objectives, because that's directly where these questions are coming from. So let me show you. When I was back on, so this this is configuring settings in the BIOS. We need to understand the BIOS because they ask questions about that, right? Explain the importance of motherboard components. Now, they have a simulation on the test where you have to identify every part that's on the motherboard. Every single part. Now, the thing about the test is everybody is not going to get all the simulations. You might get the motherboard simulation. I go get the test. I don't get the motherboard simulation. You know what I'm saying? You might get 5 sims on your test. I might only get 1. It's randomized. So that's why you have to familiarize yourself with everything. But the information that you need comes from understanding these objectives. And that's why with Professor Mesa, if you go to his videos, they go along the objectives. You see? BIOS and UFI, motherboards, RAM. This goes according to the objectives for the test, which most video series do. So you need to familiarize yourself with the objectives. Most definitely. Because if you don't know what the objectives is, you're going to be lost. Motherboards, compare and contrast various RAM types. We now at DDR4. At the making of this test, they weren't up to DDR4 yet. The difference between SODIMMs and DIMMs, parity and non-parity, ECC and non-ECC. We're going to go through all of that.
Wait a second. They got DDR4?
Yeah.
That's not going to be on the test, though, right?
No.
Okay.
But, look, installing and configuring expansion cards. We'll talk about all of these. But that's the thing. You got to familiarize yourself with the information and the objectives because that's where the questions will come from. You see optical drives, the different optical drives are like your CD, your DVD, your Blu-ray, right? Those are your optical drives. Hard drives, magnetic hard drives are the basic hard drives that we're familiar with. The ones with the spinning platters. Those are the ones that we usually buy. Because they're cheap, you get a whole bunch of storage for a little bit of money. Hot swappable drives, we'll talk about that. And then solid state flash drives, we'll talk about those too. But this is all information that is straight from the test. Install and configure storage devices and use the appropriate medium. Now, these books are going to have a whole bunch of information about the capacity of these different mediums, but you might get 1 or 2 questions about it. So the more you're familiar with, the higher your probability of being able to answer the question correctly, which is why I told y'all, putting your eyes on as many questions as possible is going to help you in this process. Questions?
I get it. I recognize everything right here because I put my eyes on about 75 questions a day.
Right. So you see here we got different socket types. We need to know what the 775, the 1155, the 1156, we're going to talk about all of those. When I said when it comes to CPUs, that's what you need to know, because let me show you something else. Where was I going to go to? If we go here, right, and we go, please, I want to go to A plus, where am I? I can't see y'all, I'm blind. A plus 901 practice test, right? So say we go to the exam compass, right? Practice test. The main functionality of the basic input-output system, the BIOS, is to perform the initial hardware checks after the computer is powered on and start up the operating system. True or false?
True.
This is not the thing I wanted. Hold on, give me 1 second. I don't want to take y'all all through my whole, I gotta go into my email. Give me a second. Any questions about what we talked about with regard to the objectives so far?
No, I just know that I have to go back over them again.
Okay. Let me go. But that is a very, like, you need to familiarize yourself with the objectives. Really? What is that? Somebody is giving me the mean feedback. I can hear myself like 2, 3 times. What is the... Oh my God. What is the page that I was looking for? With the flashcards. Wait a minute. Quizlet. That's it.
Oh yeah, Quizlet is lit.
Yeah, Quizlet is lit.
That's how I made it through my last half of college. All the exams that my teachers had, they was off of Quizlet. I found them questions.
Okay, so let's see. Flashcard. Let me see if I can show you what I mean. Oh, whoa. I ain't want no sound. Hold on. Y'all can hear that?
No. So with the videos, we had to post a link in the chat box.
No. I was just trying to, because I was hearing it in my ear. I was just trying to figure out if you can hear it. Okay, so let me see. This is, no, I don't want it to be that. What with cables, identifying, networking, memorization, motherboard, CPUs. Let me look for what? 901. Oh, here we go. So if we go with, no, I need to turn the sound off of these things because it's killing me. I just want to look at the flashcards. Okay, so let me show y'all what I'm talking about. Where's my share my screen? Hold on 1 second, y'all. Can I help you? No, ma'am. Give me a second. Can you see my screen?
Yep.
Okay, so it'll say what is the Intel socket T, right? And you need to know that when you see T, it means it's the LGA 775. You understand what I'm saying? So when it comes to CPUs, those are the kind of questions they're going to ask you. Socket B is the 1366, which is only for i7s. That's that next level That's like one of the highest level processors that they are. But the 1156, right? That's a really common one that you're gonna see. The 1155 and the 11. That's the H1. The 1155. Flip it. That's the H2. So the 1156 is, y'all see how the 1155 came after the 1156? So it's like the 1155 was the improvement on the 1156. It's crazy, but we need to be able to identify. If you see a question that asks about the H2, you know it's the 1155. And if you see a question that asks you about the H3, you know it's the 1150. This is what I'm saying when it comes to the objectives. You see right here? These are the ones that they're going to ask questions about. And we need to know. And we need to familiarize ourselves with those terms and that information. PC connection interfaces. We're going to talk about the difference between USB 1.1, 2.0, 3.0. It's a speed difference. All of this stuff, you need to know that that's going to be part of the objectives that we need to familiarize. Pin counts. You're going to see some questions about pin counts. You would drive yourself crazy trying to figure out, oh, this kind of memory has this many pins. This kind of connector has this many pins. But they will ask you that. Select the appropriate components for a custom PC configuration. Oh, yeah. So, you might have a simulation. Let me see if I can show you how to picture. Hold on. A plus simulation. So where is it? Where is it? The one about the. These are actual simulations from the test. So look, this is the one that say. Oh, I don't know if that's clear. Okay, can you guys see that? So you see it says a customer N has requested 2 custom PCs, one to be used for gaming and the other to be used as a virtualization workstation for her business. The gaming PC should support the latest games and gaming peripherals. The virtualization workstation should be able to host several production virtual machines as a part of Ann's home business. Instructions. Use the tabs at the top to switch between. Yeah, you can't really see the tabs on this, but it'll have a tab here that'll say gaming PC, and this one says virtualization PC, right? And then you see over here. Can y'all see my mouse moving or no?
Yeah, that's it.
Okay, so over here on the left side has the components that you have to choose from. So the simulation is going to tell you to drag and drop the right components to the right system, right? So like here it has, dang, I want to be able to control. This is kind of blurry, but if you look here, it says one is a 750 watt power supply and another one is a 1,000 watt power supply. You see that? So you need to know which one of these needs the 750 and which one needs the 1,000. And the only way you know that is if you familiarize yourself with this objective, which says graphics, right? Graphic heavy needs a multi-core processor, high-end video, maximum RAM. Virtualization needs maximum RAM and CPU cores. Gaming needs multi-core processor, high-end cooling, high-def sound card, and high-end GPU. So this tells you that the difference between a virtualization station and a gaming, you see all of this that a gaming PC needs compared to what you need for the RAM for the virtualization station. So that would mean that for this scenario, you need more power for a gaming station than you would for a virtualization station. You understand what I'm saying? Because graphic cards alone pull ridiculous amounts of power. So you have to familiarize yourself with the objectives and the information from that to understand, okay, in this situation, I'm going to put this 1,000-watt power supply over here on the gaming PC, and I'm going to put the 750-watt over here on the virtualization PC. This is an actual question that's going to be on the exam. Exam Campus has good questions, but there are resources out there that will give you a closer match to what you're actually going to see on the test.
Yeah.
So, like I said, you see over here it says liquid cooling, right? You know you need more cooling for a gaming PC than for a virtualization. So you will put the liquid cooling over here in the gaming PC. Whereas dual monitor display, depending, you might need a graphic card. You definitely know you're gonna need it for the gaming PC versus the virtualization. Why? Because your objectives tell you for this type of PC, these are the important aspects. For this type of custom system, these are the important aspects. Y'all understand what I'm saying? So familiarizing yourself with the objectives is a very important part of this process, because if we go back here to, let me see, did anybody, oh, okay, if we go back here, where's my professor message page? It's probably under, let me move. Sorry, y'all. Oh, there it is. Having to move stuff around. So these go according, and a lot of video sets and stuff that you'll see go according to, and you see when he talks about CPUs, what he's talking about. Socket types, characteristics, CPU cooling. It's going to be a whole lot of extra information in these books about what you need to know, but in order, you have to hone in on these objectives, you know what I mean, to know what you need to know to pass the test. You need the information for when you go out into the real world, you need to fix something. But the point of what we're trying to do is to make sure that we can get the information we need to pass this certification test. Yes? Let me see. So, this video is going to talk about all of the ones that I was just showing you in the flashcards, the 775, the 1155, the 1156, the 1366, the 1150, and I forgot the last one. You just need to know, when you see socket H, it means this. When you see socket T, it means this. You got to put those pieces of information together. Everybody following me?
Yeah.
Anybody have any questions? No? No question?
Yes, Queen,
Uh-huh.
can you the objective file, can you upload it to the Facebook page?
Yup. Let me see something. Hold on, give me 2 seconds. I could do it right now. And y'all gonna have me looking around for stuff. Okay, hold on.
You just have to upload the file. Yeah, upload file. There you go.
Mm, 901. 901. Objectives. Save. And 902. Objectives. Save. Now, so both of them are there. So now nobody could say they're not familiar with the objectives. you realize that it is very important to understanding what we're doing in this process.
I think you guys said in the very beginning too that it's probably best to take the 901 and 2 within very close to one another, right?
Yeah, well,
Yeah, that's correct.
that's what. Yeah, when with the first class that I was in, we talked. Well, you was in the first class, right?
Yes, I was.
Okay. Yeah, not you, Demonte. Um, I just feel like for me, a lot. It's like I said when I took the test. I took the 901 on Saturday, which got me pumped up to take the 902 on Monday. I feel like putting it that close together works because they build on each other. Like a lot of times people try to separate and say 901 is hardware and 902 is software. But a lot of the information that you gain from 901 is you need to know for 902 and vice versa. So my recommendation would be take the 901 and give yourself a day or two, a little bit of space to where if you need to retake the 901, you have some space. Or take the 901, you know what you're familiar with, then you know what you know what I'm saying, need to brush up on going into the 902. But that would be my recommendation. Take one and then take the other one. I wouldn't sit on the information way after because preparing for the test, getting closer to the test, it's gonna be about repetition, right? And putting your eyes on as many questions as possible. Let me so we're as we go on, I feel like I need to Charles, the flashcards are on Quizlet. There are of good a lot of good flashcards on Quizlet. Like hundreds and hundreds of if you just search for A plus, make sure the 901 because if you're looking at the older ones, it's not really helping you, right? There are a bunch of different sets of flashcards and questions on Quizlet. You see, this gives you pictures of the different connectors. You need to be able to identify them. Cables. So it's a lot of good uploaded information in 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 Quizlet. Quizlet has a bunch, and it's free access. Like you don't have to pay for access to Quizlet unless you're a teacher to be able to uh, use it to create. I want to see if I think that as we get along and the more information we get, I'm gonna get some games going so that you can so we can play against each other. It helps. It really, really helps. So look, this is more so like a question you will see. Wait a minute. I want this to not have sound. It's killing me. Where was the? I was just on it. Wait a minute. Oh, go back. Ports. Ports are gonna be very important. This is part of the. It's some stuff that is about reading, and it's other stuff that's about memorization. Memorization, memorization. You're gonna need to know all these port numbers and what they correspond to. Where? Oh, here we go. You are going to need to know the port numbers. FTP is port 21. Why? Because it's going to ask you a question. It's going to say, a person is having a problem with his secure shell. What port does he need to have open? 22. This is something you need to memorize. Is no getting around it. So as we go on, I'm gonna be asking questions like I'm gonna be like so and so. Run down all the ports for me, cause you need to know all of them. But see, for me, when it comes to memorization, I try to connect things to things that I already know, right? So, for instance, Telnet is 23. So for me, Telnet was Michael Jordan, 23. Michael Jordan is number 23. When I saw Telnet, I thought Michael Jordan. That's gonna make me remember. I don't know what makes other people remember, but if for you relate it to something you already know, it makes it easier for you to remember. But all the port numbers we need to remember. 53. Yeah. So, um, it's all in their objectives, right? But Quizlet is a great resource. I'm gonna be sending you guys out a tester. I need to get some more practice tests, but um, it's just some things that we gonna have to remember. Is a lot of information that we're just going to have to remember. A technician cannot communicate with one particular IP address. It needs to narrow down where the traffic is stopping. Which of the following commands would you use to determine this? Traceroute. You got to know what traceroute is to be able to know that that's how you track down where traffic is stopping, where traffic is going. So these are like actual questions that you, type of questions that you would see on the test. Huh. Sasha said, anybody interested in being her study partner? That's, let me tell y'all, I had a study buddy when I was getting ready to actually go take the test. Me and him used to be looking at questions 2 o'clock in the morning. Like, let me show y'all something. 901 VCE. VCE PDF. I'm trying to think what was the page that I was on that you could. So when I say put your eyes on as many questions as you can, this is what I mean. This document is 63 pages, and it has, let me see, 156 questions, and this is one of the shorter ones. I'm telling y'all, this is one of the shorter ones. Users have started calling the help desk reporting they cannot access resources on the network or the internet. A technician has verified all hardware connections are operational. Which of the following settings should the technician check next on the router? See that? Answer. DHCP. Because DHCP is the resource that gives out the IP addresses. So there are a lot of documents like this out there that you can look at actual questions. Put your eyes on as many. A technician is tasked with setting up a workstation in a new location. The technician realizes there's no network connectivity and the workstation's NIC does not have a link light. Given a connection to the wall is correctly labeled, which of the following would be best for the technician to use next? A cable tester. You know, it might be a situation that with the cable. As much as we can read, as much as we can do flashcards, you got to put your eyes on as many questions as possible. This is one of the PDFs that doesn't have the sims in it. But some of them actually have the simulation questions where you can see some of the simulation questions. Let me see. And I'm just saying that's how I was able to get it done. Looking at as many questions. Why is it not showing? Oh, this one has 50 something. Yeah, 50 something pages. I'm trying to see if it has any graphics so I can show you some of the simulations. But literally understanding and looking. But like I said, the book and reading the information and watching the videos will give you the information. And then when you have the information and then you're able to go and look at questions and be like, a group of users need to connect directly to a printer with continuous access. Which of the following connection types will achieve this? Continuous access. Ethernet. Always connected, always on the internet. You know what I'm saying? Like, we're going to have the information and combine the information with questions, flashcards, games, images, to be able to get through as many questions as we can to be able. See, this is one of those things that we looking at, we might not. I see what I could do. Remember we had that conversation about stuff that but even though it's private, we know it's not necessarily private. I don't have a problem with that though. Just understand, we got to make sure we limit the people's access to what we use and what we see. I don't have a problem uploading. But we shouldn't be at the point where we looking at questions right now. We need the information, right?
Yeah.
So we need to be able to get through the information. Your best friend is the book, videos, cybrary.net, is it net? is another place where they have full sets of videos. And then I know one of the brothers shared that he had access to a bunch of video series, and maybe because I was looking at it from my phone, it said that the folder was empty, and maybe I was tripping. Maybe it was because I wasn't on my computer.
Soraya
But
posted it.
oh, that's Cyberry. Yeah. So you gotta register on Cyberry, but they have full sets, full sets of courses.
Oh yeah, that's a great site right there.
They have full. You see, they have the whole A plus, Cloud plus, Linux, Network plus, Security plus. They have full sets of all, like the whole video series. And Professor Mesa, this is a really good resource. He keeps the information concise. His voice might be a little drab and boring for some people. I don't have a problem with it.
Eli the computer guy is another good one.
Yeah, Eli the computer guy on YouTube. I don't know if he has like full sets. The thing I like about um when when I went to the folder, they said they were empty. And maybe, is this my inbox? Hold up. And I said maybe it was because I was on my phone. It was because I was on my phone, because there they go. So yeah, brother Eon shared out links to his Google Drive that has videos full set. It's a beautiful thing. So I know he said anybody send their email address to him and he will help give them access. He had done a post in the room. So what we're gonna do, people, I'm gonna give us an assignment to watch and do research on all that you can about processors. So we can talk about processors when we come back. Deal?
That is a deal.
We straight.
I'm gonna need y'all to do your studying though, right? Cause we it's gonna be a lot of information to get through, and we gonna hit these bumps where we're not necessarily gonna be getting through a whole chapter, because we might go, in another direction. Like today, like I didn't realize how many of you hadn't really focused in on the objectives and understanding how important knowing the objectives and connecting the objectives to the information you read, the videos you watch. That's the beauty of, like I say, Peter is not necessarily a fan of Professor Mesa, but Professor Mesa is my friend. And he has a lot of good, and is objective based. That's why I like it. You know what I mean? Like it goes through each section with each of the objectives, and all the way straight through.
And
You know what I mean?
Queen,
Yes.
this is Brother Inyon here. I just want to add on that I highly recommend the CBT Nuggets video series in the folder, and the Plural site is also really good. I do have the Mike Myers video series. I haven't gone through that one, so I can't speak to the quality of that. But I know he obviously does good work. But I really like the CBT Nuggets.
It might make some sense of this book.
Yeah, I mean, it's supposed to go along with his book, so.
So you said you do have access to that?
Yeah, all of it's already in the Google Drive account. If you have access to it, to
Okay.
the folder, you already have access to all that stuff.
So it might. we might find ourselves in a space where we might get. Oh, Jay said he couldn't hear you. Jay, brother. Oh, you can't hear just him. Oh, brother Eon was saying if you have access to his Google Drive, then he has all the videos there. And I think that going forward, we're gonna try to make this like maybe I'm gonna I'm gonna tell y'all to read the book, but for class, I think I'm gonna go through like if the book is saying we're gonna talk about CPUs, then I'm gonna bring together links to all the CPU videos, right? So that we could, because I know that one of the other web sharing resources that I used to use, you can play the video through it. WebEx, I don't think does that. WebEx is like you just send a link and then you gotta watch it on your own. But I feel like if we could watch it all together, then if you will see, like people could pull a different bit of understanding from each video, and then we could discuss it as a whole. 'Cause I know we used to do it in a class where you post a link and then everybody watches it individually. Then you say, "I'm done," and then we go from there. But if I could find a way for us to watch together, so that as we go along, like, wait a minute, Mojo, stop right there. I don't get that. What do they mean? Right? And somebody else might have gotten a better understanding from it, or we could stop right there and discuss. You know what I'm saying? So we'll see. But I'm gonna try to see. I'm gonna. I think that I'm going forward. I'm gonna try to make it more interactive. So if we talking about CPUs, we're gonna make sure we go through all the CPU videos. We understand, and maybe in that we make sure we're taking notes, right, of the stuff that we need to connect to the objectives. So you know your socket types, and you know your this, and you know your that. So we can like put the pieces together as opposed to just going straight through the book. But we all each have to read the book. Agree?
Yeah. Hey, Queen,
Yes.
are there videos on any of these sites you mentioned where they actually show the different components in the computer? You said they're going to be asking that on the test, right?
Yeah. So
Eli has a video like that.
Eli, the computer guy.
Yeah, he has a video where he like shows the components. Like he yeah, does the breakdown and the build or the build of it, I believe.
And I also encourage you guys, if you find a really good resource, right, like for the topic that we're talking about, if you find a really good resource, share it in a group, because everybody might get something from it. You know what I mean? If you don't like, oh, whoa, Eli, I am Eli, the computer guy. Okay, so Eli does have a lot of good videos.
Yeah.
Um, components. Anatomy of a computer. That looks like that might be good.
That's the one.
And that's an hour long.
Yeah,
So.
I remember Peter used to distribute them hour-long videos and be like, "Good night."
Right. And that's the thing, like, I don't want us to be we all sitting in the group together, sitting watching the video separately for an hour, as opposed to if we could somehow, if we give the assignment for the video and then we discuss it or whatever going forward. I think that it's probably going to be better for us going forward if it's not necessarily just follow the PowerPoint and discuss the book, but a group discussion about whatever chapter it is that we're talking about.
Mm-hmm.
Because it seems like if we stay just with the book, and if somebody didn't read the book, then they're lost. When we could just have a general discussion about CPUs, a general discussion about RAM, a general discussion about ports. You know what I mean? So I think that's how we're gonna do it. going forward. What folder is exam cram in, Eon?
I gotta run. Good night, everybody.
Oh yeah, guys, it's 10:20. So we all know that our homework is CPUs. As much information as we can get, and we can look, and we can put our eyes on about CPUs. And if you find a good CPU video, post it in the room, and then we'll all discuss it. And then I'm gonna pull together what resources I want to give to you guys while we're in the room and for us to discuss, and then we'll go from there, okay?
Okay.
Everybody good? So homework,
Very good.
research for CPU, and in relation to the 901, right? We don't just want to look for CPU stuff, and it's not going to help us with the test that we're trying to take. So any A+ 901 resources that refer to CPU, whether it be Quizlet games, Quizlet flashcards, videos from Professor Mesa, Cybrary, the videos that Brother Eon shared, everything that we could pull together about CPUs. So we could put a good, all of us know this about CPUs by the time we finish with Thursday's class.
Hey, Queen, real quick, do you have is there like a local resource like Barnes and Noble or something I can actually get my hands on physical flashcards?
Oh. Like, I don't even remember the last time I touched a physical flashcard. I think I made them based on the electronic flashcards that I see. Like, I usually only use Quizlet because it's so many.
Gotcha.
But actual physical flashcards, I haven't. I don't have a resource.
Print them off on paper and just cut them up, I guess.
Right, you could print them from Quizlet, and then, you know, if you could print double-sided, so you got the answer on one side and the question on another side, you might be able to do that.
Cool.
And I know, like, everybody has their own study thing that works for them, and some people need that physical piece of paper. Be like, I need this in my hand to look at it, as opposed to just like when I'm at work, everybody take notes in Notepad, and I write everything in a notebook. Why? I don't know, because I never did before, but it works for me now. I don't know why, but everybody, I'm making mine from index cards, and I'm gonna work my husband to death. I hear that, Carrie. I need to find me a husband to work to death, but that's another story. Anyway, y'all have a good night. Our focus is CPUs. Share all resources that you find so that we'll be able to pull it all together on Thursday, and then we'll go CPUs, and then we'll move forward from there. Okay?
Sweet.
Thank you. Love y'all. Missed y'all. I'm glad I'm back. I'll be having a lot going on with all these kids, but I'm here for y'all. Don't worry about it. We're going to get through it together. Have a good night, everybody.
Peace.
You too.